All right, today we're in lesson 54 and 55. We're going to talk about two different things. One is using linear programming, there in lesson 54, and the other is finding probability. Linear programming is somewhat complex, okay? Let's start off by doing some typing and some reading here. Let's talk about what linear programming is, okay? I'm going to do some typing up in here. Let's see, lesson 54, using linear programming, okay? All right, what is linear programming? Let's see, Corey, can you tell me what linear programming is? And I'll try to type it while you're talking.
Linear programming is a mathematical technique that allows you to make optimal decisions from a complex set of choices. Linear programming would be looking for the maximum value of an objective function subject to a certain constraint. The constraints are given as a linear equation or a equation.
Okay. They give you a couple of different things that they're stating here. Like we said, is a mathematical technique that allows you to make optimal decisions from a complex set of choices. For instance, I don't know how many of you work, let's say, any of you guys work on a farm or have a family farm? Some? Okay, I see a hand going up. Okay. Farming is somewhat of a complex type of thing whenever you're looking at trying to get the most out of your money. For instance, let's see, Lexi, do you have beef cattle or any kind of livestock? Horses. Okay, so you want a healthy horse, but you also don't want to spend too much money, right? So to get the healthiest horse, or if we're talking about raising steers or something like that, or raising goats. And typically, the reason I switch over to kind of cows and goats and things like that, those are typically things that we raise and we're trying to get them to weigh the most, be the healthiest, all this and that. And so linear programming would allow me to do something along the lines of, if I had 3 types of feed, right? And they had different components to them. Some of them have higher fat content, some of them have higher calorie content, some of them have higher protein, and they have different costs. Linear programming would allow me to take all those different variables and give a chart where I could find the most efficient way of feeding my livestock that's going to get the most gains at the lowest cost. Does that make sense? Right? And so it is very complex. These are difficult questions, but for the most part, what we're taking is 3 linear inequalities and finding the darkest shaded region, right, and making a decision based upon where that darkest shaded region is. And so we might look for minimums, we might look for maximums. How many of you want to maybe own your own business someday? Anybody in here want to own your own business someday? Okay, just one of you. Everybody else wants to work for somebody else, right? Corey wants to own his own business. What kind of business do you want to own, Corey? You want to own a mechanical business? Amy? Makeup? Okay. So in business, what is it ultimately that you're desiring to have or to gain from owning your own business? It's a really simple question. Money. You want the most money. And you also, at the same time, you want the lowest expenses, right? So if you were going to, say, produce a product, right? Let's say you were going to make your own makeup, right? You would want to be able to make your makeup at the lowest cost and have the highest margin that it's still going to sell at, right? Because if you sell it for too much, nobody buys it, right? If you sell it for too little, you don't make enough money. So linear programming problems allow us to find the answers to these very complex questions, right? How can I make the most money by spending the least amount of money? How can I get the greatest gains, without having to spend so much? How can I spend the least and get the most, right? That's essentially what linear programming tries to do, okay? And so when we get further on into this, it says in linear programming, you are looking for the maximum and minimum value of an objective function subject to certain constraints. So a couple of words that we want to make note of there are objective function, okay, and constraints. Constraints are going to limit us, things that we can't go beyond. Okay? Say I own, and later on we'll look at a question that involves owning a publishing company where we are willing to spend up to but not over a certain amount of money to publish a certain book. Right? That's a constraint. Okay? Or we're willing to sell it for so much money but not over that, or maybe not under that. Okay? Those are going to give me constraints. Okay? Beyond that, we see some other words that show up. Let's see. Jose, would you tell me about feasible regions?
In the graph, the shaded area is known as a feasible region where all possible solutions are found. When evaluating a solution, a key area to focus on is the corners of the feasible region, also known as vertices.
Okay. Where all feasible solutions are found. Okay, so anything that will work will be in that shaded region. When evaluating a solution, a key area to focus on are the corners of the feasible region. We want to look at the vertices. Okay, these are places where those lines connect. Okay, vertices. All right, and that's really the biggest part to what they're showing me here. Okay, we've got objective functions, we've got constraints, we have feasible regions, and specifically we want to look at vertices. Vertices are going to be sets of coordinate pairs. Okay? Or XY locations. Okay? All right. Before we move on, and we'll cover some questions from this, let's go on over to Lesson 55 so we have some information here. Lesson 55 talks about finding probability. Okay, that's where we're going to be with Lesson 55. Okay, but I don't want to lose ground on 54, so let's look at some questions from Lesson 54. Let me get over to where I need to be. I thought I had that pulled up. Okay. All right. So this gives me that small publishing company. A small publishing company is planning to publish 2 books this month, Book A and Book B. The publishing company, cost is $6 each for Book A and $8 each for Book B. The total cost can be no more than $7,200. The company cannot publish more than 560 copies of Book A and 720 copies of Book B. The profit per Book A is $10. The profit per Book B is $15. Find a number of books of each type that the company should publish to maximize its profits, right? Now, this is where we get into math where it's not a situation where when am I ever going to use this? Even if you don't own your own business, how many of you plan to work for a business someday? Okay, more hands go up here. Can you imagine if you worked for an employer that produced a product and you knew how to maximize your employer's profits? Do you think that they might be somewhat pleased with you? Right? If you could find a way to save them money and to maximize their profits, you might be looking at, hey, maybe a raise. All right, so let's look at some things. We need to write some equations for some lines. We're going to write some inequalities. We're going to do this step by step because it's a lot of information. All right, the publishing company's cost is $6 for Book A. So for every Book A, it costs them $6, right? If my substitution for A was 1, we know that our cost would be $6 to 12, 3, 18, so on and so forth. So we're just going to write that up as 6A, right? What is their cost for Book B? $8, all right? All right, so we're going to put 8B. Okay? Now, our total cost can be no more than what? $7,200. Okay? $7,200. All right? So I want an inequality. Is 6a plus 8b going to be greater than or equal to 7,200 or less than or equal to 7,200? Okay, I've got a mixed bag here. I've got some less than, so I've got greater than. The total cost can be no more than 7,200. All right? So I can be less than 7,200, right? And I could be equal to 7,200. Is that correct? All right, so I know I can get an equal to, but I need to be less than. Okay? 6a plus 8b is less than or equal to 7,200. Okay? Now, we can keep going on. We can write some more inequalities. The company cannot publish more than 560 copies of book A. So we could write and say that A is to 560. Is it greater than? Is it less than? Is it equal to 560? What do we think? Use less than, because I can produce up to 560, but can I go over 560? No, so I want to be A is less than 560. All right, keeping that in mind, what would I write B up as? What do you think? Less than, equal to 720. Okay? All we're doing right now is we're putting together the information that we have in a way that we can streamline it a little bit. Okay? The profit for book A is 10. The profit for book B is 15. So, in a sense, profit-wise, A equals 10, B equals 15. Okay? Now, let's see, what I want to do here is, so that we're using coordinates that we're familiar with, is that I'm going to do some substitution, some variable substitution. I'm going to say that A equals X and B equals Y. Okay, because that's going to help us see this a little bit better. Okay? So I'm going to rewrite this as 6X plus 8Y is less than or equal to 7,200. Okay? Now, could I take this and solve it so that it is an equation in slope-intercept form? Sure I could. Okay? How would I go about doing that? Subtract 6x from both sides. Okay? So I've got 8y is less than or equal to negative 6x plus 7,200. Okay? Divide by 8. Okay, kind of running out. Let's see if I can squeeze some more space here. Yeah. Okay. Let's see, let's go over here. Actually, I want to change the way that we're doing this here for just a second. Okay? We're going to do something that's going to deal with finding x and y intercepts. And whenever I say finding x and y intercepts, if I'm looking at something like this on a coordinate plane, this is the x-intercept, right? This is the y-intercept. I want to show you quickly how to find an x and y-intercept. If I want to find the, let's say, the x-intercept is what I get whenever y equals 0. Okay, does that make sense? Okay. So we're going to do this. We're going to find our x and y intercepts. Okay? So with this, right, the first thing I'm going to do is I'm going to plug in 0 for y. Okay? If I plug in 0 for y, 8 times 0 is what? 0. So what I'm left with is 6x is less than or equal to 7,200. So if I wanted to find x, all I have to do is what? So 7,200 divided by 6, which is what? 1,200. Okay? That is my x-intercept. I would come out over here to where I found 1,200, right? And I would put a dot. Okay? Now if I want to find the y-intercept, what do I need to do? Plug 0 in for x. Okay? So what's 7,200 divided by 8? Okay? So 900. All right, so I would come up here to where I found 900. I'd put a dot. Okay? All right, does that make sense? So those would be two coordinates that I would plot. All right, I may have to move over here for a second. Hold that information for me, and I'm going to come over here. Okay, and we're going to extend this page on down a little bit further. All right, so our information. All right, so far we had my x and y. I had 0 and 900. I had 1,200 and 0. Okay? Have I lost anybody up to this point? We feel pretty good about this? Okay. All right. So we want to find our constraints. So we're going to do a couple things in here. Okay. Let's go back here for a second. I want you to see something. I want you to look at some of these answers that they got. We can erase that. Okay, remember how we talked about A equals 10? Okay, the profit for A equals 10. Okay, so that is a line, and x, if A is my x, and B is my y. Okay, we said A equaled 10. A had to be less, or sorry, A equaled 10. And my profit for B was 15. Okay? All right, we know that. The other thing was A was less than or equal to 560. Okay? Well, A is x. So if x is less than or equal to 560, okay, we're going to make our x equals line. X equals a vertical line at 560. That's where you see this line here, correct? All right, and if it's everything less than 560, which side of that line is going to be shaded, the left side or the right side? The left side. So I would shade everything over here. Okay, you follow me? All right, my profit on, on B, I can only make 720, or up to 720 of those. Okay? Well, if y is less than or equal to 720, y is a what type of line? Horizontal line. So I'm going to find at 720 a horizontal line. Now keep in mind, I can only make up to 720. I could make less. So which side of that line am I going to shade? I'm going to shade down. Okay, and if you'll notice, remember my coordinates from earlier? My x, y coordinates were what? 900, 1,200, okay? And 900, 0, okay? So x at 0 goes up to 1,200, right? It was the other way around. Oh, you messed me up. Okay, we'll fix it. All right, 0, 900, 1,200, 0. Okay, so we want to go up to 900. Notice that that's right there. We want to go across here to 1,200. Notice that that line is right there. Okay, now that line is represented by how many books we can make. Can I make more than that number of books? No. So which side of the line should I shade? Should I bring it more closer to 0 or away from 0? closer to 0. So what I'm going to do, so what we should notice is that this area right here is my feasible region. Do we see that? Okay, I know that looks kind of crazy and messy, but that's my feasible region. Okay, what time do we get out of here? 10:36? Okay, so we're going to end up finishing a lot of this tomorrow. So what I'm going to do is I'm going to erase this. Okay, because what we wanted to look at is within the feasible region, what is the most important part to the feasible region? Let's go back to those notes. The vertices, right? The vertices. Okay, feasible regions where all possible solutions are found. Vertices, sets of coordinates, are those most important parts. Okay, so we're going to come back in here. We're going to look at these vertices. Okay? All right, and we're going to put them back into our equation for profit. Okay, our equation for profit was 10a plus 15b equals what? Well, remember, a is x and b is y. Okay, so we want the highest profit based upon those coordinates. Okay, so we have 4 coordinates. All right, so I'm going to go 10, 0 plus 15 times 720. Okay, you guys are going to help me out here. All right, we know 10 times 0 is 0. What's 15 times 720? 10,800. Okay, so that's this guy right here. Right? If I make 0 of book A and I make 720 of book B, my profit's 10,800, which sounds good, but it may not be the most. Okay, let's keep going. Let's go to the next one. That would be 240 plus 15 times 720. Okay, and I'm going to help us out here. That's going to be 13,200. Okay, if we come down here and we plug that guy in, we got 564.80. He is 12,800. We come down here to 560.0. We're going to get 5,600. So where's my highest profit? Is it 10,800, 13,200, 12,800, or 5,600? No, not 12,800. It's 13,200, which was right here. So those coordinates are this and this. So of book A, I need to make 240. Book B, I need to publish 720. We'll finish this lesson tomorrow.